For my presentation and my hypothesis test, I chose hurricanes in the Atlantic Ocean versus the Pacific Ocean and their wind speeds. For this project, I have used a website created by NOAA, the National Weather Service, the National Hurricane Center, and the Central Pacific Hurricane Center. I used an article on the FEMA website titled Into the Storm, Hurricane Hunters of NOAA gather the data we need to protect our communities, which basically discusses how the hurricane data is obtained. I also used the hurricane satellite data, or the HurStat, created by NOAA to help me decide further if this is the topic I wanted to pursue. That topic slash hypothesis being when comparing hurricane wind speeds between the Atlantic Ocean and the Pacific Ocean in 2019 and 2020, will the Atlantic Ocean have a higher hurricane wind speed? So the null is, I'm actually just going to read the next. No, the null is the Atlantic Ocean hurricane wind speeds is less than the Pacific Ocean hurricane wind speeds. And the alternative is the Atlantic Ocean hurricane wind speeds are greater than the Pacific Ocean hurricane wind speeds. The null hypothesis in this scenario is that there is not a significant difference in wind speeds between the Atlantic Ocean and Pacific Ocean hurricanes. The alternative hypothesis in this scenario is that there is a significant difference in wind speeds between the Atlantic Ocean and Pacific Ocean hurricanes, with the Atlantic Ocean hurricanes having higher wind speeds. Here is the hurricane data from the two different oceans. The first one is the Atlantic hurricanes in 2019 and 2020. And then the second one is the Pacific hurricanes in 2019 and 2020. I did notice that the Atlantic hurricanes, there were a lot more than there were in the Pacific. There were 20 in the Atlantic and only 11 in the Pacific. Here's the data from the two oceans, the hurricane data. The previous slide shows each hurricane during the years 2019 and 2020, as well as their top wind speed. The chart above shows the quartiles, sample size, mean, and standard deviation of both oceans. Slide is about the confidence intervals. So just to give some insight, for the Atlantic, the lower limit was 99.42 and the upper limit was 129.18. The Pacific had the lower limit of 101.94 and the upper limit of 133.34. So for both groups, Atlantic and Pacific, the confidence ranges are both narrow, with the upper and lower limit ranges. They both are around 30 units apart. I am 95% confident that for the Atlantic Ocean, the hurricane's wind speed mean is between 99.42 and 129.18. I'm also 95% confident that for the Pacific Ocean, the hurricane's wind speed mean is between 101.94 and 133.34. Also, the confidence intervals of the two groups do overlap, with the upper and lower limits for both the Atlantic and Pacific Oceans being so close together, as well as the two means being only about 3 numbers away from each other. I do not see the two groups having a drastic or strong difference. The difference is minuscule. Here I have my hypothesis test results, and I had a significance level of 0.05, a test statistic of 0.3023, and a p-value of 0.7686. So in this scenario, I would fail to reject the null hypothesis because the p-value is greater than the significance level chosen. This means that there is a significant difference in the wind speeds between the Atlantic Ocean and Pacific Ocean's hurricanes. For my conclusion, in my research, my two sample t-tests had shown that between the Pacific Ocean and the Atlantic Ocean that showed a similar mean, standard deviation, and standard error, but the test provided to show that the hurricane's wind speeds between the two oceans had a significant difference. I failed to reject the null, which means that the Atlantic Ocean hurricane's wind speeds were faster than the hurricanes in the Pacific Ocean in the years of 2019 and 2020. This last slide shows the citations that I had used for this project, and that's my presentation.